Hello everyone and welcome to the OneClass channel. My name is Donna and I'm a recent master's graduate in the Materials Science program from the University of Ontario Institute of Technology, also known as Ontario Tech University. So today we're going to go over some commonly asked questions in chemistry at the high school, college, and university level. So if you needed any help with homework or with tutoring, then check out the links in the description below. So now I'm just going to get started on our set of questions for today's session. Okay, so question 1 just asks, what is the standard temperature and pressure, also known as STP? So STP, like what they mentioned, stands for standard temperature and pressure. So for the temperature, standard temperature is 273.15 Kelvin. And this is also equal to 0 degrees Celsius, or in Fahrenheit 32 degrees. Absolute pressure, on the other hand, let me just write it down. This is equal to 1 atm, which can also be seen as 101.325 kilopascals, and 1 atm is equal to 760 torr. So these are all the standard temperature and pressure values. So let's see what the junior tutor said. Standard temperature and pressure, or STP, is often used for measuring the density and volume of gas. Based on the literature, the standard temperature is equal to the freezing point of water, which is 0 degrees Celsius, which is also equal to 273.15 Kelvin. On the other hand, standard pressure is 1 atm, which is also equal to 101.325 kilopascals, or 760 millimeters of mercury, or torr. Yep, so this solution is correct. Okay, so moving on to question number 2. Pretty much just asks, how do you find the ideal gas constant? So the ideal gas constant can also be denoted as R. And I can just show how we can derive this constant. So we're going to start off writing the equation PV equals nRT. So P stands for pressure, and the standard pressure is just 1 atm. V stands for volume. And to derive R, we're going to look at something called the molar volume, which has a value of 22.4 liters. So N stands for moles. So I'm just going to make it 1 mole. And T is temperature. So standard temperature is 273 Kelvin. And now I'm just going to rearrange this equation to solve for R. So it will be pressure times volume divided by number of moles times temperature. And now I'm just going to input all of the values that I have written up at the top there. So pressure 1 atm, volume 22.4 liters, all divided by 1 mole, and the temperature 273 Kelvin. Okay, so now we can solve for the R constant, which gives us a final value of 0.08205, and the units are liters times atm over mole times Kelvin. Alright, let's see what the junior tutor said. The ideal gas constant R is present in the ideal gas law equation, PV equals nRT. Solve for the value of this constant, let the conditions in STP, P equals 1 atm and T equals 273 Kelvin. Also, in 1 mole of gas, the molar volume V is found to be 22.4 liters, and derive the equation to solve for R, then substitute the given. Okay, so they rearranged it, R equals PV over NT, and they also got the value of 0.08205 liters times atm over mole times Kelvin. So I can verify that this solution is correct. Okay, so on to question 3. Simply asks, how many atoms are in a mole? So to answer this question, we are going to look at Avogadro's number. So Avogadro's number has a value of 6.022 times 10 to the 23, and the units are atoms per mole. So Avogadro's number helps us answer a lot of different things that we could be looking for, like number of atoms. We can also use it to look for number of particles or number of photons. It all just depends if we have our number of moles first. So the junior tutor said there are 6.022 times 10 to the 23 atoms in a mole. We know this since a mole is defined as the number equal to the number of carbon atoms in exactly 12 grams of carbon-12. This number is also called Avogadro's number. Yep, so this solution is correct. They also gave some background on where they got the number from. That's pretty cool. On to question 4. What is the molar mass of K? So K stands for the element potassium. And to find the molar mass of potassium, we simply just need to look at the periodic table. So it's equal to 39.1 grams per mole. The junior tutor said the molar mass of potassium is 39.1 grams per mole. The molar mass of an element can be found in the periodic table as the atomic weight / atomic mass. So here they just have an example of what it would look like if you were to find it on the periodic table. The number in the top right, which is the 19, that is the atomic number of potassium. So it also tells us how many protons are in the element. K is the symbol for potassium, and at the bottom gives us the atomic weight, which was the 39.10. So this solution is correct. Moving on to question 5. What is a disproportionation reaction? Disproportionation reaction. So this can also be known as like a redox reaction. This means that there are products that are formed by both oxidation and reduction reactions. Okay, so the term disproportionation reaction isn't widely used. People just tend to refer it as a redox reaction. Okay, so let's show an example. So let's say we had mercury, 1 chloride, so the reason why we know that the mercury has an oxidation number of 1 is because each chlorine atom has an oxidation number of -1. And since there are 2 chlorine atoms, it has a total charge of -2. And we can see here that we needed 2 atoms of mercury to neutralize the 2 chlorines. So that means each mercury atom had a charge of +1. So let's say mercury 1 chloride reacts and becomes just liquid mercury plus mercury 2 chloride. Okay, so again, we know that the oxidation number this time for mercury is +2, and this is because only 1 atom of mercury is needed to neutralize 2 atoms of chlorine, each with a -1 charge. So we can see here, if the oxidation state of mercury increased from +1 to +2, we can say that the mercury was oxidized. And that is one example of a disproportionation reaction. Or another one, let's say we had phosphorus acid forms phosphoric acid plus phosphine. Okay, so let's balance this equation. There are a total of 6 hydrogens on the product side, and there's only 3 on the reactants. We'll also notice that there are 2 phosphines on the products, 1 in the reactants, and there are, I think this should be PO3. Yeah. 4 oxygens on the product and 3 in the reactants. So I'm going to put a coefficient of 4 in front of the phosphorus acid, 3 in front of the phosphoric acid, and now the equation should be balanced. Yep, so that's another example of a redox reaction. So let's see what the junior tutor said. A disproportionation reaction is a chemical equation, typically a redox reaction, where a molecule is transformed into two or more dissimilar products. Happens in redox reaction where only a single molecule undergoes both oxidation and reduction. The deproportionation reaction, can be represented by the following equation. 2A makes A prime plus A double prime, where these are all different chemical species. The reverse reaction of the disproportionation reaction is called combustion. One common example of a disproportionation example is the conversion of hydrogen peroxide into water and oxygen gas. Yep, so this solution is correct. On to question 6. How many quarts are in a gallon? There are, in fact, 4 quarts in 1 gallon. The junior tutor said, the conversion of a gallon to quarts is defined by the following formula below. 1 gallon is equal to 4 quarts. Therefore, there are 4 quarts in a gallon. Yep, so this solution is correct. On to question 7. Draw the structure of the neutral product formed in the following reaction. Okay, so we have a compound here that contains 2 ester groups. And you'll also notice this methyl vinyl ketone. And then they also react with methanol. So let me just draw out our first reactant. Okay, so the role of the deprotonated methanol is that it acts as acid or a base, sorry, and it deprotonates our starting product. Okay, so once it takes the hydrogen, the electrons move here, and then there is a negatively charged oxygen. But if I were to draw this structure to show how the charge can be stabilized, it will look like the following. Since realistically the negatively charged oxygen doesn't just stay on the one oxygen atom, it will kind of look like this. And it's kind of shared in between both. Okay, so I'll just write that step 1 was the deprotonation. And now what happens in step 2, we draw the second reactant up here. Move it over a bit. Okay, and it also contains a carbonyl functionality. So this negative charge comes in and attacks the carbon, and then I'll just draw the movement of electrons going up like that. So this step is the nucleophilic attack. So the nucleophile reacts with the electrophile. So this is also can be called conjugate addition. Okay, so moving on down, I'll draw what this structure looks like after that second step. And I'll also show the new bond that was formed right here. So now we have a negatively charged oxygen and a new double bond formed here. So I'm just going to draw another molecule of methanol. And I'll show that this negative charge comes down. This double bond gets reduced. And then we are left with our final product. So just to complete all the steps, step 3 can just be called proton extraction or abstraction maybe. All right. So let's see what the junior tutor said. The given reaction is the reaction between dimethylmalonate on the left and methyl vinyl ketone on the right. Here, the alpha hydrogens of dimethylmalonate are considered extremely acidic. Hence, once deprotonation occurs, the conjugate base is balanced out by 2 carbonyl gatherings. So this is shown here in step 2. Because of this, a base in the form of methanolate deprotonates the acidic hydrogen of the dimethylmalonate, producing an enolate. After which a 1,4 assault or Michael assault occurs to the ketone, giving a final product shown below. Yep, so this solution is correct. I think they just forgot to put the 2 oxygens at the top there, but I'll just make a note of that. But the solution is still correct. Um, yep, so the explanation was correct. I just added that the two carbonyls in the dimethyl malonate should still have its oxygens in the final product. Okay, so question 8 just asks, what is the molar mass of magnesium oxide? Okay, so to answer this question, we would need the atomic masses of both magnesium and oxygen. So these values are just found on your periodic table. So the molar mass of magnesium oxide is just the molar mass of magnesium plus the molar mass of oxygen. So since there is only one atom of each, I don't need to multiply their molar mass values by anything. Okay, so the molar mass of magnesium is 24.31 grams per mole. And the molar mass of oxygen is 16.00 grams per mole. So adding these two values up gives us a final molar mass value of 40.31 grams per mole for magnesium oxide. Okay, so the junior tutor said, in calculating the molar mass of a compound, the molar mass of each element is multiplied to the number of atoms and summed up. The molar mass of each element can be obtained from the periodic table, in brackets atomic mass, and the number of atoms is indicated by the subscript of each element in the chemical formula. Okay, so they showed that we only had to multiply the atomic masses of magnesium and oxygen by 1, and then they added the values up to get 40.31 grams per mole. Okay, so this solution is correct. Question 9 just asks, how many cups are there in a quart? Well, there are 4 cups in 1 quart. Okay, so the junior tutor said, in general, we know that 1 pint is equal to 2 cups, and 1 quart is equal to 2 pints. Solving for this, 1 quart times 2 pints over 1 quart times 2 cups over 1 pint is equal to 4 cups. Therefore, 1 quart is equal to 4. Yep. So this solution is correct. Okay, so question 10 asks, how do you calculate the enthalpy change of combustion? Okay, so let me write out the definition of enthalpy change of combustion. And its symbol the delta symbol stands for change. So delta H is enthalpy. Then I'll just put combustion down there. So enthalpy change of combustion is the heat, energy, given out when 1 mole of a substance burns completely in oxygen. Okay, so let's have an example. So let's say we had a hydrocarbon propane plus oxygen the products of every combustion reaction is CO2 and water. Just write the states. Okay, so now let's balance this equation. There are 3 carbons on the reactant side, so we need 3 carbons on the products. There are 8 hydrogens on the reactant side, so I need to put a 4 in front of the water, since H2O contains 2 atoms of hydrogen. So now on our product side, there are 6 plus 4, so this gives us 10 oxygens in total. So I just need to write a coefficient of 5 in front of the oxygen. Okay, so usually in a question that asks for the enthalpy change of combustion for the whole reaction, they give us the delta H of formation for all of the reactants and the products that are involved in the reaction. So I'm going to write down all their values at the bottom. So for the propane, it has a delta H of formation of negative 105 kilojoules per mole. So pure oxygen gas has a delta H of formation of 0. Carbon dioxide, its value is negative 394 kilojoules per mole. And in the case of water, it is negative 286 kilojoules per mole. Okay, so to answer this question, I'm going to write the general expression to find the enthalpy change of combustion for this reaction. So generally speaking, this is equal to the sum of the delta H of formation of the products So notice that I put N, which stands for number of moles. So this depends on how many moles there are of each substance. So the sum of the enthalpy change of formation of the products minus the sum of the enthalpy change of formation of all of the reactants. Okay, so I'm going to write down all the values so that we can see what this would look like if we were to plug in all of our values. So first, for our products, it's going to be 3 moles So first, let's look at the CO2. So 3 moles times negative 394 kilojoules per mole. Next, this is going to be added to 4 moles times the negative 286 kilojoules per mole from the water. Okay, so those are all of our products. And now I'm going to minus, and I'm just going to continue the line at the bottom here. So for the propane, there's only 1 mole, and its delta H of formation value is negative 105 kilojoules per mole. And lastly, there's 5 moles of oxygen, but its delta H of formation value is 0. So we know that this will just cancel out when we do our final solving of the answer. Okay, so if you were to calculate this whole thing, the units of moles all cancel out, and we get a final value of negative 2,221 kilojoules. Okay, so let's see what our junior tutor said about this question. It may depend on the problem given, but in most cases, the enthalpy of change of combustion can be computed using Hess's law, which is the same as the enthalpy of formation. Given that you have the combustion of alcohol with the general formula CXHY, the combustion reaction is written as, and then they have our coefficients shown as well. So ACXHY plus BO2 makes CCO2 plus DH2O, where A, B, C, and D are the coefficients of each species in the reaction, which will depend on the balancing of the reaction. Okay, so this is similar to how I balanced our combustion reaction in the example. And Hess's law states that the enthalpy of reaction is the sum of all the enthalpy change present in the reaction, regardless of the number of steps it took to go to the current reaction we are paying attention to. In the equation, we have delta H of formation, or of the combustion, is equal to the sum of the delta H of formation for the products minus the sum of the delta H formation of the reactants. So it is important to know the enthalpy of formation of each species present in the reaction. Using the combustion reaction given, the calculation of enthalpy of formation, or the enthalpy of change of combustion, is the following. So you can see how they showed that you need to put the number of moles into account when you need to calculate for the enthalpy of formation. Okay, so they did C times delta H formation of CO2 plus D times delta H formation of H2O. All of that minus A times delta H formation of your alcohol or your hydrocarbon. Lastly, plus delta B of the delta H formation of O2. So that B should be in front of the delta sign. But nevertheless, this solution is still correct. Alright, so moving on to question 11. What is the specific heat of water? So specific heat can also be expressed as C. So the specific heat of water is equal to 4.18 joules over, this is just grams times degrees Celsius. So this means that we need 4.18 joules to increase the temperature of 1 gram of water by 1 degree Celsius. So let's see what the junior tutor said. Water has a specific heat capacity of 4,200 joules over kilojoules times degrees Celsius. So it's the same value, but instead of grams, it would be 4,200 if it was kilograms. So this means that we need 4,200 joules in order to increase the temperature of 1 kilogram of water by 1 degree Celsius. So the solution is correct. Okay, so on to question 12. How do you solve for the mass given the density and volume of the material? Okay, so let's recall the density equation. So the units of density is in grams per milliliter or grams per centimeter cubed. And it is equal to mass in grams over volume. So again, this can be expressed in both milliliters or centimeter cubed, depending on whether or not you have like a solid or a liquid. So the symbols, so this is my attempt at drawing a row for density is equal to mass over volume. So if we're given density and volume of the material, all we need to do is rearrange this equation so that we solve for mass. So it's going to be density times volume. So let's see what the junior tutor said. The formula of the density is given by density equals mass over volume. Multiply the volume on both sides of the equation. Yep. And then they got mass is equal to density times volume. So hence, to calculate for the mass, multiply the density by its volume. For example, a regular piece of wood has a dimension 4 by 3 by 4 centimeters. So 4 centimeters by 3 centimeters by 4 centimeters. And a density equal to 0.55 grams per centimeter cubed. To solve for its mass, the volume of the wood is calculated first. So to calculate the volume of a rectangle or cube, it is length times width times height. So 4 centimeters by 3 centimeters by 4 centimeters gives us 48 centimeter cubed. After solving for the volume, use the obtained equation to solve for the mass use the given density. So mass is equal to the 0.55 gram per centimeter cubed density times 48 centimeter cubed, which was found in the previous step, which gives us a mass of 26.4 grams. Hence, the piece of wood weighs 26.4 grams. Yep, so this solution is correct. We also had a good example showing how to calculate the volume of like a rectangular piece of wood. That was pretty cool. Okay, so one last question for this session. What are the properties of the OH minus ion? So the OH minus can also be known as the hydroxide ion. Okay, so I'll always also draw its Lewis structure. So here are all the lone pairs on oxygen. And this has a -1 charge. So the hydroxide ion can be used as a base. It can also be used as a ligand. It can act as a nucleophile since it has that negative charge. And it can also just be a catalyst. Okay, so there's a lot of different functions for the hydroxide ion. And the junior tutor said, the hydroxide ion, OH-, is a diatomic ion of hydrogen and oxygen. The hydrogen and oxygen are covalently bonded with oxygen having a negative charge. The chemistry of hydroxide ions revolve around its ability to act as a base, a ligand, and a nucleophile. Hydroxide is a strong base because its conjugate acid, water, is weak. This also makes it a poor leaving group. Because of its charge, it is also a good nucleophile. Yep, so this solution is correct. Okay, so I just noted that they had a great summary of all the different functions of OH-. Okay, so that sums up all the questions that I had. So if you liked today's Q&A and you'd like to be notified of when we do this next, please hit the subscribe button and notification bell below. If you wanted to submit a question of your own, then check out the links in the description. And also, if you liked today's video, go ahead and give it a thumbs up and comment. And don't forget to share it with all your friends and classmates if they needed any help with chemistry. This has been Donna from OneClass, and I hope to see you soon. Bye.